All right, so today we are going to be doing 16.3 sector area. On page 873, we are going to first look at the explorer of how do they get the area of the formula for the area of a sector. It says a sector of a circle is a region bounded by two radii. This is a radius, and two of them is radii, and their intercepted arc. So we are talking about this area here. How are we going to figure out the area of that? Well, let's look at an example they have here. We have a radius of 15 and a degree measure of 120. I want to find out how much space this takes up. Well, if we figure out the entire area of the circle and then we say, well, what is just the portion of this? We could multiply it by the proportion and we'll find out how much area that is. So the area of a circle is pi r squared. We know our radius is 15, so pi times 15 squared. 15 squared is 225, so this is 225 pi. Or we could say 225 times pi, which is going to be approximately 706.8, maybe 0.9 millimeters. We have 120 degrees. Now we're gonna 120 out of 360, so we're gonna multiply this number by 120 over 360 times 706.9 because it's out of the entire circle. If I just left it as 360 out of 360, then I'd be multiplying by 1. Our area wouldn't change, but our proportion is 120 out of the 360. So we're going to multiply it by 120 divided by 360, and we'll get 235.6 millimeters squared. And this one should have been squared as well. So instead of talking about our degree measures over 360, we're just going to write down our formula that we're using. So the area of a sector is just take the area, multiply it by how much our measure is over 360. Just like our arc length was the, what did we say the arc length was? Our, I don't know, we'll call it that. M over 360 times 2 pi r. The area of the sector is just the same thing, the area multiplied by m over 360. And the rest of this is just going to be using that as our example. So if we wanted to go ahead and try, well, I'll just skip this because this example is done for us. So let's just go on to B. If we want to figure out the area of this sector, we'll say this is going to be pi times 12 squared times 131 over 360. It doesn't matter if I put it here or I put it in the front. I just put it here because I didn't have any space, but we'll just move it around here so we'll get used to seeing it like that. So this is pi 144. And then you could just use your calculator for this. Then that's what I'm about to do. So if we want to leave it in terms of pi, we'll do 131 times 144. That's going to be hopefully divisible by 360. I don't think it is. 52, okay, 52.4 pi. And then we can approximate that because if we wanted to just, this is our most accurate answer. However, if we wanted to round, because let's just say this represented how much pizza you're going to eat or how much space something was going to take up, then leaving things in terms of pi doesn't make sense. But if it's the most accurate answer, we want to leave it in terms of pi. So those would be our two reasons for rounding answers or leaving them. We want to put our units, which is meters squared. So meters squared here. Okay. It says here on this reflect, your friend says that the value of m degrees in our formula for the area of a sector can never be larger than 360. Do you agree with that? So think about it. Pause the video. Okay, well, let's think about what if m was bigger than 360. Could we have more than our circle? And it doesn't make sense for our circle or for a measure of our degrees to be bigger than 360. So we can't do that. So it has to be less than or equal to 360. All right, also go ahead and do number 4 and number 5. Why don't you go ahead and pause these, figure out these two areas. All right, I'm going to do them right now. If our diameter is 1.6, then that means our radius is going to be 0.8. So we'll say pi 0.8 squared times a half of a circle. So 1/2, or I could have said 180 over 360, but no need to do that. We'll just do a half. That's going to be a lot easier. So we have 1/2 pi 0.8. That's going to be 0.64. Half of 0.64 is 0.32 pi, or approximately 1.0, to round to the nearest hundredth, so 0.005, that's going to be 0.01 centimeters squared. And then for our second one, we have 22.5 over 180, or over 360, times pi r squared, so pi 24 squared. 24 squared is 576. 576 times 22.5 divided by 360. It's going to be 36 pi, which is approximately 113.1, 09, yeah, that rounds to 1 millimeters squared. Make sure to put your units squared. We're going to have a couple of word problems that uses these examples. It says here that the beam of a lighthouse is visible of a distance of 3 miles. When it says words like that, that means we're talking about a radius, because we talk about a lighthouse and it's going to be going around in a circle and it's going to have some distance. That's going to be 3 miles. To the nearest square mile, what is the area covered by the beam as it sweeps an arc of 150? So they already did the work for us, but I'm going to go ahead and draw the example here. So here's our lighthouse. We're going to put in the center. Here is our distance of 3 miles, and it's going in an arc of 150 degrees. So 150 over 360 times pi 3 squared, which is how they got 9 pi. So they simplified 150 over 360 to 5 over 12 to make the multiplication simpler. So let's draw this one here, and whenever we get any word problems, we want to draw out our example so we know what we're talking about. We have a circular plot. It has a 180-foot diameter, which means that our radius is going to be half of 180, which is 90 feet. It's sprayed to rotates an angle of 50 degrees, so we have 50 over 360 times pi 90 squared. So 90 squared is kind of a large number. I'm going to multiply that by 50, so that's 8100 times 50 divided by 360. So we got 1125 pi. Or approximately 34.3 feet squared. Now, in this case, it doesn't make sense for us to leave this in terms of pi because we want to talk about how much area is actually being watered by the sprinkler. This is going to make more sense of our answer than the 1125 pi. All right. So you're going to go ahead and do your assignment. And I'll see you guys later today.